Hey Chemsters, this is Mrs. Vanderwaaij bringing you the very first edition of your flipped classroom notes. And before we really begin, let's talk about the expectations of the flipped classroom. So this is where you are watching this video, you are taking notes, and you are following along, and the expectation is that you are focused, you are paying attention, you're not on your phone, you're not texting, put them away, you're not watching TV, you're not jamming to some music because you should be listening to me. And then the next day we talk about them. We will do problems together. We will discuss any questions you might have. We may go into a little bit more further depth. We may have a lab. So the idea is that you watch the video at home and then you do the problems in class. The reason why it's called flipped is that usually it's the other way around. Typically you do notes in class and then you do the problems at home. Here it's the opposite. Now we are not going to just totally flip this classroom. We'll do some flipped and some not. So just hopefully that helps you out. Again, if you have any burning questions, you can always contact me through email or through the Remind app. If you have other questions that are not quite so burning, you can jot some things down, and I will always start the next day is, do you have any questions? Do you need any further clarifications? Do you want to go over any more examples? And that way we can answer those questions as well. Okay, so why don't you go ahead and put all your distractions away and let's get started. So chapter 1 is about matter and change. So we're starting with the very basics, and what we cover in this chapter we'll cover in more detail down the road, but it's just an introduction to what we're doing. So it's usually a good idea to define what the subject is that we're going to be spending, this whole year up and through May. What are we talking about? So what is chemistry? Well, here we go. Here's the actual definition. Chemistry is the study of the composition, structure, and properties of matter, and the processes that matter undergoes, and the energy changes that accompany these processes. Well, composition, once you underline that word, what is composition? It's like, well, what makes up stuff? Okay, structure is, well, how they put together. Properties are, well, what do they look like? What do they taste like? Though we shouldn't taste in the chemistry lab, I know. What do they feel like? That kind of things. Those would be properties. And the process that matter undergoes. Does it melt? Does it react? And the energy changes. Does it give off heat? Does it require heat? Does it give off sound? Does it give off light? Those would be energy changes that accompany these processes. So there's a word that shows up several times in that one sentence, and that word is matter. So the question is, all right, well, what's matter? And the classical definition is anything that has mass and occupies space. So just think about that. What are things that you can think of that has mass and occupies space? So why don't you pause this and jot down a few of your ideas, and then we'll talk about this. So pause, write, and come back. So what kind of things did you come up with? Well, this is what I came up with. I have a desk. Does a desk have mass? Sure, you put it on a scale, it's going to show something. Does it occupy space? Well, yes. Well, what are you sitting on? You're sitting on a chair, I hope. So does that have mass? Does it occupy space? That's a good thing. All right, how about some other things? How about water? Does a glass of water have mass? Yes. Does a glass of water occupy space? Sure. Here's something else. What about air? Does air have mass? Yes, it does. Does air occupy space? Yes, because if it didn't, then maybe you have a black hole. I don't know. But air has mass and air occupies space. I got one more for you. You matter to me. How's that? All right, so what are some examples of what is not matter? So go ahead and think about this. What does not have mass and what does not take up space? So pause this, and what do you come up with? All right, welcome back. So these are some things I came up with. How about sound? Does sound come up or have mass? No. Does it take up space? No. How about radio waves? Do they have mass? No. They occupy space? No. How about light? What about heat? So my next question is, what do these four things have in common? They're all examples of what? Energy. Now go back and look at our definition again. They are the study of composition, structure, properties of matter. Do these all have composition, structure, and properties? Yes. Can these undergo changes? Yes. But how do they undergo those changes is energy. So all these things can affect all of these things, or, some of them more than others, obviously. If you heat up your desk, it'll eventually may, melt, all right? If you heat up water, it will become a vapor, all right? If you, cool down air, it's going to become, condensation. Can sound affect things? Sure, you can affect things by sound. You can break a glass by having the right frequencies. All right, so yes, those things will have a change to accompany any of those processes. Okay, so the next thing we should do is break down, well, what are your different areas of chemistry? And as a chemistry major, that I had to take classes in each of these areas. I had to take organic chemistry, I had to take inorganic, I had to take analytical, I had to take biochem. So they're a more specific area of studying chemistry. Okay, so let's check this out. So probably one of the more common or well-known area of study for chemistry is organic chemistry. And organic chemistry is a study of all chemicals containing carbon. So you're thinking, well, how hard can that be? All right, you're just looking at carbon. Oh my, can carbon do a lot of cool stuff? So what are some examples of organic compounds or organic chemistry? Here's one here. That's sugar. That is a simple sugar like fructose or glucose. They all have that same general formula. If you want to talk about like sucrose that you put on your cereal in the morning, that'd be C12H22O11. Notice it has that same CHO, and notice that the H and the O are always double each other. So that's why they call it a carbohydrate. Okay. Here I came up with another one. This is the building block of plastic, okay? So organic chemistry, all your plastics and things related to that would also fall under organic. And here's another one. That's actually, if I were to draw it out, I would show you it's a structure of an amino acid. And I don't know if that sounds familiar. You've already taken biology, but that's a building block of your proteins and things like that. What do they all have in common? Well, what's the first element in each of those formulas? It is carbon. Okay, so inorganic, this is huge. All right, study of all chemicals that do not contain carbon. So anything else out there that does not have carbon in it will be considered inorganic. So sodium chloride, that's salt, table salt. So NaCl, there's no carbon in that. And here's another really very common one, and that's water. Water is inorganic, and there's a lot of chemistry in that too. Biochemistry is a study of processes that take place in an organism. So I just came up with a couple of them. I came up with photosynthesis that takes place in your plants. Your protein synthesis takes place in your animals, and those are both organisms. I could show you, formulas and whatnot, but that's okay. Just knowing that these take place in a living species would be your biochemistry, okay? And let's go down. We have analytical, is the study of the composition, okay? So for example, I wrote, what is the formula of an unknown substance? So what would an analytical chemist do? Well, you're given this unknown white stuff and go, well, what is it? What's in there? And they would perform a bunch of chemical tests and try to break it down and see what is actually in it. So from there, you can come up with its actual formula. You go, oh, it's calcium carbonate, after you're doing your stuff. Well, what else would an analytical chemist be interested in? Is knowing what is the percentage. Let me get this up here. Hang on. There you go. What is the percentage of carbon in gasoline? So if we do know a formula of a substance, we can say, well, okay, well, how much of each compound is in there? So if you look at your food label, perhaps, okay, an analytical chemist might be very interested in what is the percent of potassium in this? What is the percent of, fat in this? That would be something else they would be looking at, okay? So let's go on. So the physical deals with the mechanism, the rate, and the energy. There we go with the energy again. The energy transfer that occurs when matter undergoes change. So what is a mechanism? It is what are your steps involved that you start from what you have and you end up with what you get. So if you take a deep breath right now, everyone take a deep breath. Exhale. Like 21 steps just had to occur for you to breathe in and then breathe out. So that would be the mechanism. What are those 21 steps? The rate is, well, how fast did it take to breathe, okay? How fast did each of those 21 steps go? Is there something in your body that's going to slow down those mechanisms, if you will? And if that's the case, then you're having a breathing problem, all right? And the energy transfers that occurs when matter undergoes change. Well, why do you breathe? Well, you breathe to get energy. So all of that, just the fact that you're breathing has a lot to do with physical chemistry. Is there anything else? Well, how about this? There's something that might be near and dear to you. How much energy, there we go, does 1 gallon of gasoline give off? All right, isn't that important for you? Well, it depends on your car, I understand. But, that would be a physical chemist. We're talking about energy here. And another thing is how fast, come here. Nope. There we go. How fast does that gasoline burn? Have you ever thought about this? What happens if that gasoline burns too fast? Your car could blow up. What happens if that gasoline burns very slowly? You're not going to go anywhere. All right, so, how fast? That's your rate. How fast does it go? Finally, this is not in your book, by the way, but there's nuclear. That's another branch of chemistry. It's a study of an atom's nucleus. Its changes in composition and mass and energy. So, the first thing is that we're going to study is, well, we will study this, how many protons, neutrons, electrons are in a sample of plutonium. How's that? That's your nucleus. So what's in your nucleus? Your protons and your neutrons. Are there changes that can undergo? And of course so. Plutonium is used in, it was used in the second bomb that we dropped on Nagasaki, actually. It was a plutonium bomb. So yeah, it has definite changes in composition and mass and energy. And speaking of that kind of thing, how does the mass of a proton differ in hydrogen than in uranium? You mean a proton doesn't weigh the same? No, it does not. It all depends on what element it's in, and that would again be a nuclear subject, okay? So I'm going to quit the very first section of notes. If you look what's coming up, it's demo day, and I will come back and we will do demo day together. That sounds like fun. All right, so hey guys, don't wait to be great.